Warahmatullahi wabarakatuh. So today our group from JCS 143-2B will present the application of differentiation in physics. First thing first, I would like to introduce you the members of this group, which is the first one we have Hani, Nabila, Binti, Halim. The second presenters Haikel, Syazwan bin Mahamad, Ajamaain. And the last one we have myself, Mahamad, Iqbal bin Jufri. So for the first thing in this presentation, I would like to explain you the definition of differentiation. So differentiation is about a process of finding the derivative or rate of change of a function, while in contrast to the abstract of nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions.
There are 3 basic derivatives. First, algebraic function, which is real number. Second, trigonometric function. And lastly, the exponential function.
So, also in physics, we have derivative used in the calculation in physics. So there is 3 situations when we need to use differentiation to calculate it. Okay, so we have 3 situations, which is when we are about to calculate the velocity, the acceleration, and the last one is momentum and force. Okay, so for the first one, velocity, it is about derivative of position with respect to the time, which is we use the formula of d equal to ds over dt. And then for acceleration, it is about the derivative of velocity with respect to time, which is the formula we use is a equal to dd over dt. And the last one is momentum and force. Momentum is mass with times with the velocity, which is the formula is v equal to mv. So this p is stands for the power.
Related rates problem involve finding a rate at which quantity change by relating that quantity to others quantity whose rate of change are known. The rate of change is usually to respect to time. Differentiation is met in many engineering and science problems, especially when modeling the behavior of moving subjects.
Got the question of differentiation. How we solve the problem? Firstly, we must define the shape. In the question, it must be the shape of the question, such as circle, triangle, square, semicircle, or sphere, or else. Secondly, we have to identify the rate of change. We must identify the rate of change that are known or the rate of change that is to be found. Third, we must to determine the formula and equation. We must to construct a formula or equation that related the variable in the question. Lastly, we must to define the dy dx equation and substitute the value. Differentiate both sides of the equation and substitute all the known term or value given. And then we got the solve problem statement. Okay, this is the question. A boy is blowing a spherical balloon at a rate of 50 centimeter cube per second. At what rate is the radius of change when the radius is 10 centimeter. This is the spherical balloon. So the question asks about the rate of the radius when the radius is 10. So firstly, we must define the shape. In the question, they tell us the balloon. So the shape is sphere. Sphere is look like this. Secondly, we must identify the rate of change. The rate of change for the volume is 50 cm3 per second and the radius of the sphere is 10 cm. Third, we must determine the formula and equation. The formula of the volume is 4 divided by 3 times 2 pi times 2r cubed. Lastly, we must know the dy dx equation and substitute the value. So, the dy dx equation is the rate of change by a radius is dr divided by dv times 2 dv divided by dt. Let's go. Firstly, we know the formula of the volume is 4 divided by 3 times 2 pi times 2r cubed. So,
we differentiate the formula of the volume to 4 pi r cubed. And when we upside down, it's gonna be 1 over 4 pi r cubed.
Cube as squared. Then, we know the equation is dr divided by dt is dr divided by dv times 2 dv divided by dt. So, dr per dt, the rate of change of radius is, we key in the value 50 times to 1 divided by 4 pi r squared, so that we key in the value of the radius, that is r. So the answer is, the rate of change of the radius is 0.04 centimeter per second.
Rate of change are very connected with time, so the application will give us the specific time in our life. Student can calculate it by using the formula d over dt. For conclusion, in physics, we must calculate a lot of calculation that apply in our daily life also using this differentiation calculation. The application of differentiation is used to compute the rate of change. We can accurately count the differences in changes happen. The differentiation also include derivatives of constant polynomials, hyperbolics, logarithms, speeds, exponential, and others more.
So this is a few reference that we search from the internet. And lastly, thank you for watching. Hope you enjoy the video and learn something. Thank you.